Everyone thinks the Boeing 747's famous hump was built for luxury or looks. But in the late 1960s, airline bosses expected supersonic jets like Concorde to wipe out subsonic travel. Pan Am's Tripp issued an ultimatum to Boeing: design a giant airliner that could turn into the world's most efficient freighter in case passengers abandon these slower jumbos. Boeing's answer was radical. Move the cockpit above the main deck, creating a near mythical bump that changed aviation history. The true reason for the hump wasn't glamour, but survival. So why did this gamble make the 747 an icon, while so many rivals disappeared? The answer starts with a risk that almost no one talks about. In 1966, Pan Am's president, Tripp, faced a future that looked anything but certain. The world's airlines were betting billions on the next big thing: supersonic transports. The Concorde was already turning heads in Europe, and Boeing's own 2707 promised to cross oceans at twice the speed of sound. Industry forecasts predicted that by the 1970s, subsonic jets could be swept aside, leaving airlines with fleets of obsolete giants. Tripp wasn't willing to gamble Pan Am's future on a single outcome. He demanded more from Boeing than just a bigger airliner. He wanted a machine that could pivot from carrying passengers to hauling freight at a moment's notice. The contract signed that spring spelled it out. The new plane must be convertible, with no compromises on cargo efficiency. If supersonic transports took over, the 747 would need to transform overnight into the world's fastest, most capable freighter. Boeing's engineers understood the stakes. The cost of failure wasn't just a lost contract, it was the risk of building a white elephant, a jet that might never earn back its investment. Tripp's requirements forced the team to rethink everything about jumbo jet design. The main deck had to be a wide, flat, uninterrupted space. No bulkheads, no cockpit in the way. Only then could it handle the huge pallets and containers that defined modern air cargo. The pressure was relentless. In meeting after meeting, Tripp pressed his point. If the future goes supersonic, we'll need these for cargo, or not at all. Every feature, every inch of the design was measured against this threat. The 747's survival depended on a simple, radical promise: build a jet that could do it all, or risk being left behind the very moment the world changed. Boeing's chief engineer, Joe Sutter, stood at the center of a design dilemma that would define the 747 for decades. Pan Am's contract demanded a main deck as flat and open as a warehouse floor, ready for pallets and containers. But the problem was right up front: where to put the cockpit. If the flight deck stayed at nose level, it would block any hope of rolling cargo straight through. Early sketches flirted with radical ideas. A cockpit tucked below the main deck, nicknamed the Anteater. That solution was quickly dismissed. It complicated crew escape routes and made takeoff visibility nearly impossible. Safety regulations would never allow it. The breakthrough came from a simple question: what if the pilot sat above the action? Sutter's team raised the flight deck onto a short upper level just behind the nose. This move cleared the entire main deck from nose to tail, opening the door, literally, for a full-width, swing-open nose. Now giant pallets could be loaded in a straight line, no bends, no bulkheads, no cockpit in the way. The price was a new aerodynamic challenge. Raising the cockpit meant adding a fairing to smooth the transition, creating the now famous hump. Sutter called it a balcony for the pilots. Internal Boeing memos from 1966 show how contentious this choice became. Some engineers argued for a sleeker, more conventional profile, worried about drag and extra weight. But Pan Am's requirements left no room for compromise. The raised cockpit wasn't about luxury or looks. It was a calculated response to a commercial gamble, a design that let the 747 switch from passenger giant to cargo king at a moment's notice. The hump was born from necessity, not style. A freighter's promise lives or dies by how fast it can move cargo. The Boeing 747's most radical feature wasn't just its size, but the way it turned the nose into a giant swinging door, an engineering move that let pallets roll straight through from tarmac to tail. 16 heavy-duty latches, each motor-driven and monitored by redundant indicator lights, clamp the nose shut in flight. When it's time to load, a single command from the cargo bay control panel releases the locks. Two massive screw jacks, powered by electric motors, slowly swing the nose open to the right. The entire front of the airplane pivots away, exposing a clear, warehouse-flat deck that stretches the length of the fuselage. Loadmasters and ground crews line up roller tracks, guiding cargo containers and oversized pallets directly inside. The process is brutally efficient. No bends, no bottlenecks, no cockpit blocking the way. Standardized unit load devices, or ULDs, glide on steel rollers embedded in the floor, held in place by quick-lock pins and side restraints. For outsized cargo, oil rig modules, racehorse stalls, even helicopters, there's no other commercial jet that offers this kind of straight-shot access. The design is more than just clever mechanics. Every cycle of the nose door puts stress on reinforced hinges, pressure seals, and the forward fuselage. Maintenance logs show crews inspecting for latchware and seal leaks after every major load. But the payoff is speed. Airlines have clocked turnaround times under 2 hours for a full main deck reload. In the world of air freight, that's money in the bank. The swing nose system enabled by the raised cockpit turned the 747 into the world's fastest cargo handler, an advantage no rival could match. What began as a hedge against the supersonic future became a working legend on the ramp. The upper deck of the original 747 was a surprise bonus, not the main event. When Boeing's engineers finished raising the cockpit to clear the main deck for cargo, they were left with a small, oddly shaped space just behind the pilots. On early 747-100s, this became a lounge, a quiet retreat with a few curved sofas, a bar, maybe a piano if the airline felt daring. It was a nod to the Stratocruiser's upstairs lounge, but on a much grander scale. Airline marketing teams seized on the opportunity, filling glossy ads with champagne flutes and spiral staircases. The myth took off. The 747's hump was for luxury, a flying penthouse in the sky. Yet the numbers tell a different story. That upper deck was tiny, just a handful of seats at first. The real driver was always what happened below, a flat main deck ready for cargo. Only later, as airlines pushed for more capacity, did Boeing stretch the upper deck on the 747-300 and 747-400, turning the lounge into rows of extra seats. Even then, the hump's shape and location stayed rooted in its original purpose. No cargo logic, no upstairs bar. Boeing's own brochures from the 1970s quietly admit it. The lounge was a side effect, not a goal. For every first-class passenger sipping cocktails upstairs, 100 more were riding in the economy cabin below. Or, on some flights, the whole main deck was packed with freight. The legend of the luxury lounge endures, but the real story sits in steel and rivets. The hump was designed for utility. Comfort just hitched a ride. Wind tunnel tests in the mid-1960s revealed a harsh truth. Moving the cockpit above the main deck didn't just create a new silhouette, it brought an aerodynamic penalty. The first mock-ups, shaped like a blunt bubble, sent turbulent air streaming over the fuselage, pushing cruise drag up by nearly 4%. For an aircraft expected to cross oceans, that meant millions in extra fuel over its lifetime. Boeing's aerodynamicists pressed for a fix. Over months of testing, engineers sculpted the upper deck into a teardrop fairing, stretching it back and somehow smoothing every curve. The result? Drag dropped to about 2.5% above a clean tube. Still a penalty, but far less than the early designs. This was no minor compromise. At a time when fuel costs could make or break an airline, every percentage point mattered. Yet the team weighed the numbers against the alternative. Keeping the cockpit at nose level would have cut off the cargo highway, dooming the 747's promise as a convertible freighter. The teardrop hump was the only way to keep the main deck flat and open, ready for pallets and containers. Boeing's engineers ran the calculations again and again. The verdict? Utility won. The slight drag increase was a price worth paying for the flexibility to move anything from racehorses to oil rigs. The 747's profile became an icon, not because it was the most efficient, but because it was the most useful. That balance between aerodynamic cost and operational payoff defined the jet's legacy long before the first passenger ever climbed the spiral staircase. Time for a reality check. The 747's hump has inspired decades of wild theories, but most miss the mark. Myth number 1. The radar dome. Some believe the upper deck houses a massive weather or navigation radar. In truth, the radar sits under the nose, just like on every other jetliner. The hump is pure structure. No spinning dishes, no secret electronics. Myth number 2. Extra fuel. It's tempting to think that Bulge stores thousands of gallons of jet fuel for long-haul flights. But the facts are simpler. The 747's main fuel tanks are in the wings and belly, not the upper deck. Later models added small auxiliary tanks in the upper fuselage, but the Hump itself was never designed as a flying gas can. Myth number 3, first-class luxury. Glossy ads from the 70s sold the Hump as a floating cocktail lounge, a sky-high sanctuary for the elite. The reality? That space was a byproduct. The upper deck started small, just big enough for a cockpit and maybe a few seats. The real driver was always what happened below, the need to keep the main deck flat for cargo. Forget radar domes, fuel bunkers, and flying nightclubs. The 747's Hump exists because engineers needed a clear path for pallets and containers. Everything else, lounges, extra seats, even the iconic spiral staircase, came later. Clearing away the myths sets the stage for what made the Hump truly revolutionary. Modern wide-body airliners tell a different story. The Boeing 777, 787 and Airbus A350 glide through the sky with clean, uninterrupted nose profiles. No hump, no balcony for the pilots, no swing open nose. Their designs reflect a new era of priorities. Airlines and manufacturers now chase every fraction of a percent in fuel savings, and the old cargo-first logic has faded for passenger jets. Instead of keeping the main deck flat for giant freight pallets, these jets rely on sophisticated underfloor cargo holds. Standardized unit load devices, or ULDs, are packed into the belly, slid in through side doors, stacked and locked by ground crews with precision. For comparison, the 777's lower deck can swallow up to 44 LD3 containers, each one loaded beneath the passenger cabin. On the 787 and A350, the process is even more automated. Sensors track every container, optimizing balance and weight distribution without ever disturbing the main cabin above. This approach eliminates the need for a swing nose or a raised cockpit. The entire upper fuselage remains aerodynamically smooth, minimizing drag and maximizing range. Fleet planners now focus on efficiency and flexibility within a single deck. Modern twins can fly farther on less fuel with 2 engines instead of 4. The economics are clear: fewer moving parts, lower maintenance costs, and no structural compromises for a convertible freighter role. Dedicated cargo versions of these jets still use the belly for freight, but the main deck stays reserved for passengers. The silhouette comparison speaks volumes. The 747's iconic hump stands out against the sleek outlines of today's wide-bodies, a symbol of an era when versatility outweighed pure efficiency. Now the smooth-nosed twins dominate long-haul routes, their bellies packed with cargo, their main decks filled with travelers. The age of the convertible jumbo has passed, but the lesson remains: every shape in aviation carries the logic of its time. Before sunrise in Anchorage, a 747 freighter idles on the ramp, its nose swung open like the mouth of a whale. Inside, teams guide a massive oil drilling module, 40 feet long, weighing over 20 tons, directly onto the main deck. No other commercial jet can take it. On another continent, a herd of racehorses waits in custom-built stalls, destined for Dubai's racing season. Loadmasters walk the line, checking restraints and comfort for each animal. For them, the 747's flat deck isn't just convenience, it's the difference between a safe flight and a logistical nightmare. From the frozen supply runs of Prudhoe Bay to last-minute disaster relief in Southeast Asia, the 747's swing-nose design has carried everything from helicopters to priceless artwork. Airlines like Cargolux, Atlas Air, and Nippon Cargo have logged millions of miles on routes that connect factories, farms, and families worldwide. The numbers are staggering. Some 747 freighters have stayed in service for over 30 years, flying up to 16 hours non-stop between continents. Every landing writes a new entry in the logbooks of global commerce. Pilots and loadmasters become legends in this world. Jill Myers, one of the first female loadmasters in the 1980s, recalls flights with everything from Formula One cars to live cattle. Captain Jerry Grubb once coordinated a round-the-world animal rescue using the 747's outsized capacity to save hundreds of rare species. Each mission starts with the same ritual: testing the nose latches, inspecting the roller tracks, prepping for a main deck that can transform from industrial lifter to flying stable in a single shift. The 747's hump, born from a gamble on the future, became the badge of an aircraft that could do what no other could. Its silhouette signals possibility. If it fits, it flies. As the world's airports grow quieter for the jumbo's passenger cousins, the freighters keep rolling on, their swing-nose doors still opening to new cargo and new stories every day. In 1966, Pan Am's historic order for the Boeing 747 specified a convertible design, forcing engineers to move the cockpit above the main deck, creating the now iconic Hump. This single decision gave the 747 its unmatched flexibility, a flat main deck for rapid cargo loading, and, as a side effect, space for the upper deck lounge. Wind tunnel tests confirmed a 2 to 2.5% drag penalty, but documents and turnaround logs proved the utility far outweighed the cost. Some technical details about internal Boeing debates remain inaccessible, but the design's practical impact is clear. Today, modern jets like the 777 and A350 use underfloor cargo holds, making the Hump unnecessary for passengers. Yet 747 freighters still move outsized loads with nose doors worldwide. The evidence shows the Hump was never about glamour or fuel. It was about readiness for a cargo future. That choice made the 747 the most adaptable wide body of its era, and its legacy continues in every nose-loading freighter on the tarmac.